Prestonians. Good to have you around for another class. Today we want to consider nutrient cycling, specifically water and carbon cycle. Nutrients can simply be defined as anything from which you derive nutrients, or nourishment rather, anything from which you derive nourishment. Remember that one of the characteristics of living thing is nutrition. So we must feed to grow. So how do we obtain all those nutrients? That's the essence of what we want to look at today. So these are my expectations for you at the end of this class. I believe that you should be able to state the importance of carbon and water to life, and then the objectives, just 3 of them. Now, from what you can see on the board, it shows that the ecosystem is made up of living and non-living things. Now, from what you're looking at, it looks as if these 2 components exist in isolation, but that is not exactly what happens. That is constant interaction. Now, take a look at this. Living things are made up of non-living things, which means something must move from here to here. That is what the next slide is all about. Now, you can see the arrows, something moving from non-living to living, from living to non-living. In simple terms, it looks as if what happens in nature is that living things are constantly borrowing, let me use that word, borrowing nutrients from the non-living world, which is probably the atmosphere or the soil. Now, having borrowed, it is expected that you return, so that it continues, and that's why it is cycling. Now, we told you earlier that movement of nutrients is cyclic, which means no matter how stingy you are, even at the point of death, you still have to repay all the nutrients that you have inside you by way of decay. And that's why we said that movement of nutrients is cyclic. At the point of death, there is decay, and then plants are expected to pick up these nutrients to be eaten by living animals, and then the cycle continues. Now, without wasting much of your time, basic chemistry makes us understand that there can't be organic compound without carbon. So when we talk about carbon, its importance are there on the board. And when we talk about water, I am always very quick to tell my students. In senior school, the importance of water should be something biological. Don't tell us to wash, to drink, and all that. For digestion, components of blood, they serve as solvents in your body, which means anything that must travel in your body must travel in the form of liquid, for example, drugs. So, as stated on the board, these 2 nutrients are very important, and that is why we are considering them. Now, from what we can see on the board, every nutrient has a source. In the case of water here, the source here is the cloud. And so it comes down to us. When I mean us, I mean plants and or animals. So it comes down to us in the form of rain, precipitation, or whatever you want to call it, snow and all that. They all come under precipitation. So once you have rainfall, then that water percolates into the soil. It is taken up by plants. These plants have tiny pores, as we've taught you previously. The stomata will open, allowing water to leak through that stomata back to the source, which is the sky. That process is called condensation. So this is liquid water coming in, and this is gaseous water going back. Now there are 2 variants of evaporation on that board: evaporation proper and evapotranspiration. What's the difference? Evaporation that you have in plants is called evapotranspiration. So it comes in, it goes back. So every cycle has coming in and going back. That's the only way it can be described as cycle. Now the next one we want to look at is carbon cycle. Carbon exists in the atmosphere. That's the home. In the atmosphere you have carbon floating freely there. So how does it come into the living world? Plants use them during photosynthesis to produce food. These plants and these animals carry out respiration that remove or return carbon dioxide to the atmosphere. Now, when these plants and animals die, they form what you call fossil fuel, for example, petroleum. And once this petroleum they are burnt, you end up producing carbon dioxide too. It follows, therefore, that environments where you have abundant industries or vehicles, automobiles, they will produce high level of carbon dioxide. And so, like we said earlier, incoming into the living world, going back. So this is like borrowing, and this is you repaying. So this is the summary of what happens in water and carbon cycle. You have in, you have out. You have in, you have out. So anytime you draw or you have access to any of these cycles, take a look at the in and the out. Very, very important. Now, in conclusion, when you understand the concept of carbon cycle, you will now understand why we are not so comfortable with people carrying out deforestation. Because the more trees you cut, the less trees to take up carbon dioxide. And when carbon dioxide accumulates so much in the atmosphere, it leads to global warming and other attendant effects. We'll look at that as we continue in our class. So enjoy the rest of your class in Google Classroom. I'll see you guys the next time we are scheduled to meet. Thank you.